A mysterious object is racing toward our solar system at incredible speed, and scientists are scrambling to understand what it really is. In the summer of 2025, astronomers made a discovery that has sent shockwaves through the scientific community. A massive visitor from interstellar space that's unlike anything we've ever encountered. Some researchers are asking the unthinkable question: could this be something artificial? Today we'll explore the mind-bending discovery of 3I Atlas, and investigate whether we might be witnessing our first contact with alien technology. A rare visitor from deep space. Picture this. You're looking up at the night sky, completely unaware that something extraordinary is racing toward us from the depths of interstellar space at unimaginable speed. In the summer of 2025, astronomers detected exactly that, a massive cosmic wanderer that has been traveling through the galaxy for potentially billions of years before finally entering our solar system. This isn't just any ordinary asteroid or comet from our familiar cosmic neighborhood. This is 3I Atlas, a visitor from another star system entirely, carrying with it secrets from the far reaches of our galaxy that could revolutionize our understanding of how planetary systems form and evolve. What makes this discovery absolutely mind-blowing is that we're witnessing only the third confirmed interstellar object ever detected in human history. The rarity of such encounters means that most of us will never see another visitor like this in our lifetimes. As 3I Atlas races through our solar system at 61 kilometers per second, it's providing scientists with an unprecedented opportunity to study materials that originated around a completely different star, potentially offering our first glimpse into the composition and characteristics of distant worlds we may never be able to visit directly. The breaking discovery. Here's the moment that changed everything we thought we knew about our cosmic neighborhood. The discovery of 3I Atlas represents only the third confirmed interstellar object ever detected passing through our solar system, placing it in an extraordinarily rare category of cosmic visitors. To put this rarity in perspective, astronomers estimate that only one interstellar object larger than 100 meters crosses our solar system annually. Yet most remain completely undetected due to their incredible speed and darkness. Robert Jedicka from the University of Hawaii has calculated that detecting these objects requires perfect timing and cutting-edge technology working in harmony. The significance of 3I Atlas cannot be overstated. It joins the legendary one, I Oumuamua, discovered in 2017, and 2I Borisov found in 2019, as the only confirmed messengers from other star systems. What makes this discovery particularly groundbreaking is its massive size and unusual characteristics that are forcing scientists to reconsider their understanding of interstellar objects. Unlike typical asteroids or comets from our solar system, these visitors carry secrets from distant star systems, potentially harboring materials and information that could revolutionize our understanding of planetary formation, galactic evolution, and perhaps even the possibility of life beyond Earth. Each new interstellar detection brings us closer to understanding the true nature of our galaxy's wandering population. The discovery story. The incredible story of how we discovered this cosmic wanderer began in the final days of June 2025, when the Atlas telescope system at Rio Hurtado Observatory in Chile captured something extraordinary moving against the starfield. Larry Deneau, a key member of the Atlas survey team at the University of Hawaii, was conducting routine observations when the automated detection software flagged an unusual fast-moving object. The initial designation A11PL3Z was assigned to this mysterious visitor as astronomers worldwide scrambled to confirm its interstellar origin. John Tonry, the principal investigator of the Atlas project, immediately coordinated with observatories across the globe to track the object's trajectory and confirm its hyperbolic orbit. Within 48 hours of detection, follow-up observations revealed pre-discovery images dating back to June 14, 2025, indicating the object had been silently approaching our solar system for weeks. The challenge of detecting 3I Atlas stemmed from its path through the dense star fields near Sagittarius, where countless background stars made it nearly invisible against the crowded stellar backdrop. Once confirmed as an interstellar visitor, the Minor Planet Center officially designated it as 3Y Atlas, marking a historic moment in astronomy. This rapid confirmation process demonstrated the remarkable advancement in our ability to detect and track these rare cosmic messengers. A stranger in our midst. Alright, get ready to be amazed by the extraordinary characteristics that make 3I Atlas unlike any object we've ever studied in our solar system. This interstellar giant is racing through space at a mind-boggling 61 kilometers per second relative to our Sun. A velocity so extreme it actually proves the object originated from beyond our solar system's gravitational influence. Marco Michelli from the European Space Agency has determined that 3Y Atlas measures approximately 11.2 kilometers in diameter, making it significantly larger than both previous interstellar visitors combined. To put this massive scale in perspective, this cosmic wanderer is roughly the size of a small city, totally dwarfing the mysterious Oumuamua, which measured only about 400 meters in length. Daryl Seligman from Michigan State University pointed out that the object's brightness and size make it an unprecedented target for detailed scientific study. Unlike typical solar system objects that follow predictable elliptical orbits around the Sun, 3I Atlas follows a hyperbolic trajectory that will carry it back into the depths of interstellar space. The comet has developed a spectacular 25,000-kilometer-long tail as solar radiation heats its ancient ices, creating a magnificent display visible through powerful telescopes. This combination of extreme size, speed, and activity makes 3I Atlas a once-in-a-lifetime opportunity for astronomical research. The predecessors. To understand the true significance of 3I Atlas, we really need to look back at the groundbreaking discoveries that paved the way for this moment. The very first interstellar visitor, 1I Oumuamua, was discovered on October 19, 2017 by Robert Warwick using the Pan-STARRS 1 telescope in Hawaii. This cigar-shaped object, measuring roughly 400 meters long, totally baffled scientists with its unusual tumbling motion and mysterious acceleration that couldn't be explained by gravitational forces alone. Avi Loeb from Harvard University famously proposed that Oumuamua might be artificial in origin, sparking some pretty intense debate in the scientific community. 2 years later, amateur astronomer Gennady Borisov discovered 2Y Borisov on August 30, 2019 from his observatory in Crimea. Unlike the enigmatic Oumuamua, Borisov behaved like a typical comet, developing a coma and tail as it approached the Sun. Alan Fitzsimmons from Queen's University Belfast led extensive spectroscopic studies that revealed Borisov's composition was remarkably similar to comets in our own solar system. These discoveries established that interstellar objects come in different varieties, some mysterious and unusual like Oumuamua, others more familiar like Borisov. The cosmic journey. So let's follow the incredible path this ancient wanderer will take as it sweeps through our solar system over the coming months. Davide Farnochia from NASA's Jet Propulsion Laboratory has precisely calculated that 3Y Atlas will reach its closest approach to the Sun, called perihelion, on October 29, 2025 at exactly 11:41 Universal Time. At this critical moment, the comet will be positioned 1.36 astronomical units from the Sun, about 203 million kilometers away, perfectly situated between the orbits of Earth and Mars for optimal observation conditions. This cosmic dance includes several remarkable planetary encounters that provide unique scientific opportunities. On October 3, 2025, the comet will pass just 0.19 astronomical units from Mars, only 28 million kilometers away, potentially allowing Mars-based instruments to conduct unprecedented close-range observations. Following its solar encounter, 3Y Atlas will swing past Venus on November 3, 2025 at a distance of 0.65 astronomical units before beginning its journey back to interstellar space. Earth remains completely safe throughout this celestial ballet, with the closest approach occurring on December 19, 2025 at a comfortable distance of 1.8 astronomical units, or about 270 million kilometers. This trajectory provides astronomers with multiple observation windows and vantage points throughout the solar system, maximizing scientific opportunities. A scientific gold mine. The arrival of 3I/Atlas represents, honestly, an unprecedented scientific opportunity that has mobilized the global astronomical community like never before. Karen Meach from the University of Hawaii is leading an international consortium of researchers conducting comprehensive studies of the comet's composition, structure, and behavior. The James Webb Space Telescope, under observations coordinated by Stephanie Milam from NASA Goddard Space Flight Center, has been scheduled to conduct detailed infrared spectroscopy to identify complex organic molecules within the comet's nucleus. Alan Fitzsimmons from Queen's University Belfast has already detected unusual isotopic ratios in the comet's gas emissions using the Gemini Observatory, suggesting formation conditions vastly different from our local environment. Ground-based facilities including the Very Large Telescope in Chile and the Keck Observatory in Hawaii are providing continuous monitoring of brightness changes and spectral evolution. Bin Yang from the European Southern Observatory has identified traces of exotic water vapor with unusual deuterium concentrations, indicating the comet formed in an extremely cold environment around a different type of star. This coordinated global campaign represents the most comprehensive study of an interstellar object ever conducted, with data collection providing insights into star formation processes, planetary system evolution, and the distribution of life-building molecules throughout our galaxy for decades to come. Unanswered questions. Despite intensive observations, 3I Atlas continues to harbor profound mysteries that challenge our understanding of interstellar objects and their origins. Quanji Ye from the University of Maryland has been tracking unexpected brightness variations that just don't match typical cometary behavior, suggesting the object may have an unusual internal structure or composition. The comet's reddish coloration, observed by multiple telescopes worldwide, indicates the presence of organic compounds, but the exact nature of these materials, well, it remains unknown. Matthew Knight from the Naval Research Laboratory has noted that high-resolution Hubble Space Telescope images reveal intricate details in the coma structure that don't conform to standard comet models. One of the most perplexing aspects is the object's estimated age of 7 billion years, older than our entire solar system, which really raises questions about how such ancient materials have remained preserved during eons of cosmic radiation exposure. Tony Farnham from the University of Maryland has documented irregular outgassing patterns that suggest complex subsurface processes we honestly don't fully understand. The Discovery team, led by Daryl Seligman, acknowledges that many fundamental questions remain unanswered. What star system did it originate from? What caused its ejection into interstellar space? And perhaps most intriguingly, could there be more to this object than meets the eye? These mysteries ensure that 3I Atlas will remain a subject of intense scientific scrutiny. The alien question. Here's where the discussion takes a fascinating and honestly controversial turn that has divided the scientific community. Avi Loeb, the Frank B. Baird Jr. Professor of Science at Harvard University and former chair of the Astronomy Department, has gained international attention for suggesting that some interstellar objects might be artificial in origin. Following his controversial proposals about Oumuamua, Loeb has expressed interest in 3I Atlas, noting that its unusual characteristics warrant careful investigation of all possibilities, including artificial origins. Sarah Seeger from MIT has emphasized the importance of maintaining scientific rigor while remaining open to extraordinary possibilities, stating that we must examine every aspect of these rare visitors. The Galileo project, led by Loeb at Harvard, represents a systematic scientific approach to searching for evidence of extraterrestrial technology in our solar system. However, most mainstream astronomers, including Paul Chodas from NASA's Center for Near-Earth Object Studies, maintain that natural explanations can account for the observed properties of interstellar objects. Robert Warwick, discoverer of Oumuamua, has consistently argued that these objects, while unusual, fall within the expected range of natural cosmic phenomena. The debate really highlights the importance of maintaining scientific skepticism while remaining open to paradigm-shifting discoveries. Dawn of a new era. The discovery of 3I Atlas signals the beginning of a revolutionary era in astronomy, where interstellar objects will become regular subjects of scientific study rather than once-in-a-lifetime discoveries. Mark Norris from the University of Central Lancashire predicts that advancing technology will soon make these detections routine, fundamentally changing how we study galactic dynamics and planetary system formation. The Vera Rubin Observatory, which began full operations in 2025, is expected to revolutionize interstellar object discovery with its ability to scan the entire visible sky every few nights using advanced LSST camera technology. Michelle Bannister from the University of Canterbury estimates that within the next decade, we'll have discovered dozens of these cosmic wanderers, providing statistical samples large enough to understand their origins and distribution throughout the galaxy. Robert Yadika from the University of Hawaii calculates that the improved ATLAS survey system, now operating telescopes in Hawaii, Chile, and South Africa, will detect several interstellar objects annually. This technological revolution means that each new discovery will add pieces to the cosmic puzzle of how materials, and potentially life itself, are distributed throughout our galaxy. The age of interstellar archaeology has officially begun, promising to unlock secrets about distant worlds and the formation of our cosmic neighborhood that have remained hidden for billions of years. From its mysterious origins billions of years ago to its spectacular journey through our solar system, 3I Atlas has challenged everything we thought we knew about interstellar visitors. Whether it's a natural cosmic wanderer or something more extraordinary remains to be discovered. As this ancient traveler continues its path back to the stars, it leaves behind more questions than answers, and opens our minds to possibilities we're only beginning to imagine. Like, share and subscribe to InnoVision Tech for more incredible discoveries from the cosmos. What if we could measure how alien an object is? Harvard astronomer Avi Loeb proposed exactly that with what he calls the Loeb scale, where 0 is a rock and 10 is unambiguous technology. On October 13, 2025, an object that had already vanished behind the sun sent a signal that broke the scale entirely. Coordinated pulses of light, seen by two observatories on opposite sides of the world, blinked a message in the language of mathematics. What was it trying to say? Let's explore this together.
The night of pulses.
What happens when the sky blinks in perfect rhythm? On October 13, 2025, at exactly 2:41 UTC, that question became terrifyingly real. The Cerro Tololo Inter-American Observatory in Chile and the Mount Abu Infrared Observatory in India, separated by nearly 8,000 miles, recorded the same impossible event. 3 faint rhythmic bursts of light emerged from the darkness behind the sun. The source was pinpointed to the trajectory of 3I Atlas, an interstellar object that had disappeared from view weeks earlier. These weren't random flickers, they were structured, appearing in both optical and near-infrared bands, suggesting a controlled emission rather than a natural reflection. As Dr. Seth Shostak, a senior astronomer at the SETI Institute, has often said, a signal that is deliberately structured and information-rich is hard to explain away as a natural phenomenon. On their own, the pulses could have been dismissed as instrument noise or cosmic ray hits, common artifacts in astronomical data, but appearing identically at the same moment in 2 independent observatories, removed all possibility of coincidence. The synchronized detection transformed a potential error into a verified observation, forcing a re-evaluation of what was possible. The sky went silent, then it blinked, and the world was never the same.
Fibonacci sequence.
Is there a mathematical signature for life itself? If so, it might be the Fibonacci sequence. This simple pattern, introduced to the West in 1202 by the Italian mathematician Leonardo of Pisa in his book Liber Abaci, is built by adding the last 2 numbers to get the next one. 0, 1, 1, 2, 3, 5, 8, 13, and so on. But this isn't just a classroom exercise, it is nature's favorite building block. You find it in the spiral of a nautilus shell, the branching of trees, the arrangement of seeds in a sunflower, and even the magnificent arms of spiral galaxies. This recurrence isn't magic, it's a universal code for optimal growth, packing, and efficiency under physical constraints. So, when the light pulses from 3I Atlas were analyzed, the discovery was chilling. The intervals between the 3 bursts were not random, they were 5 seconds, 8 seconds, and 13 seconds. It was the Fibonacci sequence, broadcasted from behind the sun. This was more than just a signal. It was a message, written in a language that any intelligent species with a grasp of mathematics would instantly recognize as a hallmark of structure and intentional design. It suggested the sender understood that this pattern is one of the few constants that connects biology, physics, and pure mathematics across the cosmos.
Double confirmation.
How do you turn an anomaly into a fact? You get a second, independent witness. That's what made the 3I Atlas event impossible to dismiss. One observatory seeing strange flashes is a curiosity. It could be a bird, a satellite glint, or an equipment malfunction. But 2 observatories, on opposite sides of the planet, with different instruments and different atmospheric conditions, recording the exact same pattern signal within 0.04 seconds of each other. That is data. At Cerro Tololo, the sensors logged the bursts at precise Fibonacci intervals. At Mount Abu, the thermal imaging array recorded identical spikes, confirming the event occurred across multiple wavelengths. The odds of this happening by chance, from cosmic background radiation or simultaneous instrument failure, were calculated to be 1 in a billion. As the great astronomer Carl Sagan taught us, extraordinary claims require extraordinary evidence, and this dual detection was precisely that. The team systematically ruled out every known terrestrial and orbital source, leaving them with a deeply unsettling conclusion. The double confirmation was that evidence, forcing a stark choice upon the scientific community. Either they had witnessed an instrumental coincidence of astronomical improbability, or something out there was deliberately transmitting a mathematical sequence using pulses of light.
The golden ratio.
There is a number woven into the fabric of reality, from the proportions of our DNA to the spiral arms of galaxies. It's approximately 1.618, known as phi, or the golden ratio, and it's intrinsically linked to the Fibonacci sequence. If you divide any number in the sequence by the one before it, the result gets closer and closer to phi. When physicists analyzed the light from 3I Atlas, they found something even more profound than the timing. The second pulse was roughly 1.618 times brighter than the first, and the third was 1.618 times brighter than the second. The light wasn't just blinking, it was growing with perfect mathematical harmony, an exponential increase in energy output that mirrored this universal constant. The Nobel laureate Roger Penrose has spent his career exploring the deep connection between mathematics and the cosmos, suggesting that mathematical truths exist in a Platonic realm independent of human minds. Here it was, playing out in real time as if to prove his point. The signal was not just a sequence, it was a geometric progression, a fractal pattern embedded in light itself. This was structure layered on top of structure, a message that was not only transmitted but was itself an example of universal architecture.
The Fatima anniversary.
Why did the signal from 3I Atlas arrive on October 13th? For many, this date was not a coincidence, it was a deliberate echo through history. The event occurred on the 108th anniversary of the miracle of the sun at Fatima, Portugal. On October 13, 1917, tens of thousands of witnesses claimed to see the sun dance, spin, and emit brilliant colors before appearing to plummet toward the earth. Sociologists like Robert Bartholomew have studied the event as a case of mass suggestion and optical phenomena caused by atmospheric conditions, but its cultural and religious power remains immense. It became a cornerstone of faith for millions, a day where the heavens supposedly intervened in human affairs. Now, over a century later, another impossible light show connected to a celestial body took place on the very same day. One was perceived as a divine miracle, the other was recorded as a mathematical signal. The parallel was impossible to ignore, suggesting a potential awareness of our history and myths. A celestial body performing impossible light movements, on the same date, separated by 108 years, felt less like chance, and more like a deliberate symbolic act of communication.
NASA's blackout.
Where were humanity's most powerful eyes when this historic signal arrived? They were turned off. In a coincidence that strains belief, NASA's Solar Dynamics Observatory, or SDO, the primary satellite monitoring the sun 24/7, went offline for scheduled maintenance just 3 hours before the pulses were detected. Its live feed, which had run almost uninterrupted for over a decade, went dark without the standard public announcement that typically precedes such maintenance. To make matters worse, HiRISE, the most powerful camera orbiting Mars, had also been down since the beginning of October. Two of the key instruments that could have provided a direct, independent view of the signal's source were completely blind at the crucial moment. Preliminary spectra from observatories like the Keck telescope hint at the presence of nickel emission lines. As SETI pioneer Jill Tarter has often noted, transparency and open data are critical in the search for extraterrestrial intelligence, because verification is a global effort. With the SDO and HiRISE offline, that immediate verification became impossible, leaving the discovery in the hands of only 2 ground-based observatories. When the SDO feed returned 2 days later, the data for October 13th was simply gone from the public archive. There was no official explanation, only a chilling silence that for many became the loudest admission of all.
Harmonic resonance.
Was the three-eye atlas signal just numbers, or was it a form of music? According to the work of theorist David Sarita, the signal was a frequency map that aligned perfectly with his hyperdimensional solar model. In this framework, the numbers 5, 8, and 13 are not arbitrary. They correspond to specific harmonic resonances within our solar system. The number 5 relates to Earth's orbital position, 8 to a stable interplanetary zone beyond Mars, and 13 to a deep gravitational shell near Jupiter. Sarita's interpretation reframed the event entirely. The object wasn't just blinking a code, it was striking a cosmic tuning fork, creating brief flashes that carried harmonic energy across the vast distances of our solar system. This idea echoes the ancient concept of musica universalis, or music of the spheres, a theory the great astronomer Johannes Kepler dedicated his life to proving in the 17th century. Kepler believed the planets moved in orbits that corresponded to musical notes, creating a celestial symphony. While his specific theory was incorrect, Sarita's analysis proposed a modern version, that the three-eyed atlas pulses were a physical manifestation of the deep mathematical and resonant structure of our own solar system, a structure we are only just beginning to understand.
The Dante connection.
Could a 14th century poet have envisioned the very signal three-eye atlas would send? In one of the strangest synchronicities of the event, scholars pointed to Dante Alighieri's epic poem, Paradiso. Written 7 centuries ago, it describes a journey through a heaven structured by divine light and geometry. The ascent follows numerical patterns that mirror Fibonacci growth, with Dante describing the universe as a series of concentric spheres governed by a divine harmonic ratio. As the esteemed historian of science Owen Gingerich often detailed, these ancient models of the cosmos were built on a profound belief in a mathematically elegant and ordered universe, a stark contrast to a universe of pure chaos. The structure of Dante's heaven spiraling through ratios of light was a poetic echo of the 5-8-13 sequence detected from Three-Eye Atlas. Adding another layer to the mystery, Dante died in the year 1321. The 2025 event occurred 704 years later, a number that resonates with cyclical patterns significant in numerology and ancient calendars. Was it a stunning literary coincidence, a fluke of human pattern recognition, or was the signal deliberately echoing one of humanity's oldest ideas? That creation itself is built upon proportion and rhythm.
Observatories respond.
How does the scientific establishment react when faced with the impossible? With extreme caution. For nearly a week after the event, the Cerro Tololo and Mount Abu observatories remained completely silent, consulting with international astronomical bodies. When they finally issued statements, the language was sterile and non-committal. They confirmed the data was real, the timestamps were synchronized, and the pulses were detected. But they refused to speculate on the source, labeling it a non-repeating, transient, photometric anomaly. It was a phrase designed to say everything and nothing, acknowledging the event while stopping short of any extraordinary interpretation. Yet, the data they released spoke for itself. The photometric light curves showed 3 sharp, distinct peaks with perfect Fibonacci spacing. As planetary astronomer Dr. Frank Marcus of the SETI Institute would argue, you must first exhaust all possible natural explanations, no matter how unlikely. But here, every known natural cause, cosmic rays, satellites, instrumental errors, had been systematically ruled out by their internal reviews. The observatories published their findings not with a press conference, but in quiet technical bulletins buried in their archives. But the message was clear. The signal was real, it was verified, and it was now part of the scientific record.
The missing data.
While the independent observatories released their data, NASA remained a black hole of information. The conspicuous data gap from the Solar Dynamics Observatory on October 13th was never officially explained in any satisfactory detail. When pressed by journalists and independent researchers, the agency cited overlapping calibration schedules, a vague explanation that convinced no one. Analysts who monitored the public data streams found evidence that wasn't just missing, it appeared to be deliberately withheld, with logs showing manual command overrides, not automated maintenance routines. The specific data from SDO, extreme ultraviolet and magnetogram readings, could have revealed localized energy releases or magnetic field interactions that might have offered a natural explanation, but that data was gone. This silence wasn't just limited to NASA. The European Space Agency's solar orbiter, which was also in a good position to observe the event, issued no comment. This official vacuum of information eroded public trust and created a firestorm of speculation. As the work of pioneering astronomer Vera Rubin demonstrated, sometimes the most important discoveries lie in the data that doesn't fit our models. For many, NASA's silence transformed a scientific anomaly into a potential cover-up, leaving the world to wonder what they saw. In the end, we are left with a hauntingly simple pattern: 3 pulses of light, with intervals of 5, 8, and 13 seconds. It was a signal that used the universal language of mathematics, broadcasted on a date loaded with historical symbolism, and confirmed by 2 independent witnesses. Yet, the agencies with the power to verify it were conveniently looking the other way. Was 3I Atlas a natural phenomenon so bizarre it mimicked intelligence, or was it a deliberate message from something far beyond our understanding? A cosmic hello from a passing traveler? We may never know for sure, but its journey through our solar system served as a powerful reminder that the universe is far stranger and more mysterious than we ever thought possible. It proved that we are not just looking at the stars, something may be looking back. What do you think 3I Atlas was? Let us know in the comments below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the universe's greatest mysteries. Thank you for watching InnoVision Tech. A rare visitor from deep space is racing through our solar system at unprecedented speed, and NASA's latest data has left scientists questioning everything they thought they knew about cosmic visitors. 3I Atlas, the third confirmed interstellar object ever detected, exhibits characteristics so unusual that some researchers are considering the unthinkable. Could this ancient wanderer be more than just a natural comet? As we uncover its secrets, the implications for humanity's understanding of our place in the universe become increasingly profound and, honestly, pretty terrifying. The breaking discovery. On July 1, 2025, the NASA-funded Atlas Asteroid Terrestrial Impact Last Alert System Survey Telescope in Rio Hurtado, Chile, first detected an unusual object later confirmed as 3I Atlas. This interstellar comet was initially spotted at a distance of over 4.5 astronomical units from the Sun, activating alarms across the global astronomical community. Its detection marked the third confirmed interstellar object ever observed passing through our solar system, following 1I Oumuamua in 2017 and 2I Borisov in 2019. The initial observations revealed a hyperbolic trajectory with an incredibly high orbital eccentricity of 6.141, the highest ever recorded for any known interstellar visitor. Larry Deneau from the University of Hawaii's Institute for Astronomy immediately recognized that this wasn't an ordinary solar system object, but a rare visitor that had been journeying through space for billions of years. The object's incoming velocity of 58 kilometers per second relative to the Sun marked it as the fastest interstellar object ever detected, surpassing both Oumuamua and Borisov by significant margins. From the outset, astronomers recognized that 3I Atlas was fundamentally different, initiating a worldwide mobilization of observatories dedicated to tracking this cosmic traveler and unraveling its profound mysteries. The discovery story. Between June 25 and June 29, 2025, the Atlas system had been gathering precursor observations that would later prove crucial in understanding 3I Atlas's trajectory and properties. These pre-discovery images, retrieved from survey archives and including work by the Zwicky Transient Facility at Palomar Observatory in California, helped confirm the object's interstellar path. Sam Dean, an amateur astronomer, contributed critical early tracking data, noting that the comet's trajectory through dense star fields near Sagittarius made early detection extremely difficult. The object's path passed through crowded cosmic neighborhoods, where countless background stars created a celestial camouflage, explaining why it had escaped discovery earlier despite being in the inner solar system for weeks. John Tonry, principal investigator of the Atlas project, immediately coordinated with facilities across the globe to confirm the object's characteristics once it was detected. The challenge of identifying 3I Atlas stemmed from its approach through regions where most sky surveys don't venture due to the overwhelming stellar background. This cosmic game of hide-and-seek had been ongoing since June 14, 2025, when the earliest pre-discovery images show the object silently crossing space. The rapid coordination between professional and amateur astronomers from multiple continents underscores the unprecedented global effort invested in monitoring this mysterious visitor. a stranger in our midst. 3I Atlas exhibits characteristics so unusual they continue to baffle the scientific community and challenge our understanding of natural cosmic objects. Traveling at a staggering 61 kilometers per second relative to the Sun, it far exceeds the speeds of its predecessors like Oumuamua and Borisov, making it the fastest interstellar visitor ever recorded. Its brightness is particularly notable, with a distinct coma and tail forming as solar radiation heats its surface, causing ice sublimation that creates spectacular visual displays. David Jewett from the University of California, Los Angeles, noted that the comet's tail and dust emissions provide rare data about materials formed in distant star systems billions of years ago. Perhaps most puzzling is that its trajectory lies almost perfectly within the ecliptic plane, the flat disk where most planets orbit the Sun, an alignment with merely a 0.2% probability of occurring by random chance. This mathematical precision has prompted serious speculation about whether the object's path represents natural celestial mechanics or something far more intentional. The combination of unprecedented speed, unusual brightness, and statistically improbable orbital characteristics raises fundamental questions about whether 3I Atlas is truly a natural object, or represents something far more enigmatic that challenges our basic assumptions about interstellar visitors. The predecessors. So, to really understand the true significance of 3I Atlas, we have to take a look back at the two remarkable interstellar visitors that came before it, each bringing their own, well, unsolved mysteries. The first, 1I, Oumuamua, was discovered in October 2017 by astronomer Robert Warwick at the University of Hawaii. It immediately stunned the scientific community with its elongated cigar-like shape and honestly, its completely unexplained acceleration away from the Sun, all without any visible signs of outgassing. This mysterious acceleration just defied conventional physics and sparked some pretty intense debate about whether the object could be natural or possibly artificial. Then, in August 2019, amateur astronomer Gennady Borisov discovered 2I Borisov from his observatory in Crimea. This one proved to be a more traditional active comet, showing the typical outgassing behavior you'd expect from solar system visitors. The stark differences between these two ancient travelers, one mysterious and possibly artificial, the other conventionally comet-like, have really intrigued astronomers worldwide and, more importantly, set important baselines for comparison. Mark Norris from the University of Central Lancashire has pointed out that 3I Atlas, being the largest and brightest interstellar object yet discovered, gives us unprecedented opportunities to compare and contrast with its predecessors. This growing catalog of interstellar visitors is finally starting to reveal patterns that could unlock secrets about the diversity, origin, and true nature of these cosmic wanderers from distant star systems. The cosmic journey. 3I Atlas's trajectory through our solar system, honestly, follows a carefully orchestrated path that gives us optimal opportunities for comprehensive planetary observation. The object will reach perihelion on October 29, 2025, getting close to the Sun at about 1.36 astronomical units, positioned just perfectly between the orbits of Earth and Mars for extended observation. At perihelion, it'll hit maximum speeds of nearly 68 kilometers per second, which really shows off the extreme velocities you get with interstellar travelers. Paul Chodas from NASA's Center for Near-Earth Object Studies has calculated that while the comet poses no threat to Earth, keeping a safe distance of at least 1.8 astronomical units, its path brings it remarkably close to Mars, Venus, and Jupiter during its trip through the solar system. The precision of this trajectory is pretty striking. It allows close approaches to 3 major planets and provides optimal vantage points for studying inner solar system dynamics. Karen Meach from the University of Hawaii emphasizes that this close approach sequence is, honestly, an unprecedented opportunity to see how an interstellar object interacts with different solar environments and planetary gravitational fields. The object will pass just 0.19 astronomical units from Mars on October 3rd, followed by a 0.65 AU approach to Venus on November 3rd, creating a sort of reconnaissance pattern that seems almost deliberately designed for a comprehensive solar system survey, rather than just a random cosmic passage. A scientific goldmine. 3I Atlas, really represents an unprecedented scientific treasure trove for astronomers and planetary scientists who are studying materials from beyond our solar system. With an estimated diameter somewhere between 0.32 and 5.6 kilometers, it's significantly larger than previous interstellar visitors. That means it actually allows for detailed study of its composition, structure, and evolutionary changes as it interacts with solar radiation. The Hubble Space Telescope, operated by teams led by David Jewett at UCLA, has been tracking dust emissions and nuclear activity, revealing ongoing sublimation of ancient ices and continuous dust release from the object's surface. These observations are providing crucial insights into the comet's volatile content and primordial materials, likely preserved for over 7 billion years, predating our entire solar system's formation. Stephanie Malam from NASA Goddard Space Flight Center is coordinating advanced spectroscopic observations using the James Webb Space Telescope to, hopefully, identify complex organic molecules and unusual isotopic signatures that could reveal the object's stellar birthplace. Current analysis has already confirmed the presence of water ice, both as solid grains and vapor, along with hydroxide ions, suggesting a water-rich composition that's typical of objects formed in the outer regions of planetary systems. The ongoing research aims to characterize the complete molecular makeup, including potential carbon monoxide, methane, and complex organic compounds, offering rare glimpses into the chemical building blocks and formation processes of distant star systems. Unanswered questions. Despite intensive global observation campaigns, 3I/Atlas continues to harbor profound mysteries that challenge our fundamental understanding of interstellar objects and their origins. The object's precise nuclear size remains frustratingly uncertain because the surrounding active coma obscures direct measurements of the solid nucleus, which complicates crucial density and mass calculations needed to determine its true composition and internal structure. While spectroscopic analysis has confirmed the presence of water ice and organic compounds, the detection of other expected volatiles like carbon dioxide and carbon monoxide remains elusive, raising questions about the object's formation environment and preservation mechanisms during its multi-billion-year journey through space. Julia de Leon from Spain's Instituto de Astrofísica de Canarias emphasizes that the object's unusual thermal properties and outgassing patterns don't conform to standard cometary models, suggesting either exotic compositions or structural characteristics not found in typical solar system objects. Perhaps most puzzling is the object's remarkable preservation state. How materials billions of years older than our solar system could remain so well preserved and chemically active after eons of exposure to cosmic radiation and interstellar conditions. Some researchers are beginning to debate whether the object represents a completely natural phenomenon or exhibits features that might indicate artificial construction or enhancement, a possibility that would fundamentally challenge our understanding of what's possible in the cosmos. The alien question. The possibility that 3I Atlas represents humanity's first encounter with extraterrestrial technology has, sparked some pretty intense scientific debate and forced researchers to confront some uncomfortable questions about the object's true nature. Avi Loeb, who's Harvard's Frank B. Baird Jr. Professor of Science, has really emerged as the most prominent advocate for seriously investigating artificial origins. He cites the object's statistically improbable trajectory, its unprecedented velocity, and honestly, its unusual structural characteristics as evidence that, warrant extraordinary investigation. Loeb's analysis suggests that the mathematical precision required for 3I Atlas's path, which actually provides optimal reconnaissance opportunities while passing close to multiple planets, exceeds what we'd reasonably expect from random cosmic events. His Galileo project at Harvard has been mobilized to conduct systematic observations using multiple telescopes worldwide, specifically searching for signs of artificial construction or technological signatures. However, mainstream astronomers like Sarah Seeger from MIT and Alan Fitzsimmons from Queen's University Belfast urge extreme caution, emphasizing that extraordinary claims require extraordinary evidence and that natural explanations should be exhausted before considering artificial hypotheses. The scientific community now finds itself balancing healthy skepticism with the recognition that, if 3I Atlas does represent extraterrestrial technology, the implications for humanity's understanding of our place in the universe would be, revolutionary, and potentially terrifying in their scope and consequences. Observing the visitor. Astronomers across the globe have mobilized an unprecedented array of telescopes and instruments to study 3Y Atlas as it journeys through our solar system, creating the most comprehensive interstellar object observation campaign in history. Major facilities including the Very Large Telescope in Chile, NASA's Hubble Space Telescope, and the revolutionary James Webb Space Telescope are collaborating to collect multi-wavelength data that could, hopefully, unlock the secrets of this cosmic visitor. Michelle Bannister from the University of Canterbury notes that this coordinated effort involves over 50 professional observatories and, honestly, numerous amateur astronomers contributing observations and analysis. The Southern Astrophysical Research Telescope has been conducting detailed spectroscopic analysis to identify specific molecules and compounds in the object's coma and tail. Ground-based facilities like the Gemini Observatory and Keck Observatory in Hawaii are providing continuous monitoring of brightness changes, rotational periods, and thermal emissions that reveal internal heat distribution patterns. Canada, France, Hawaii telescope observations have captured deep images showing faint cometary activity even at great distances from the Sun. This international collaboration represents a new model for rapid response astronomy, with data-sharing protocols that allow real-time analysis and immediate follow-up observations when unusual phenomena are detected, ensuring that no critical information about this rare interstellar visitor is lost. Dawn of a new era. The detection and intensive study of 3I Atlas heralds the dawn of a revolutionary new era in astronomy, where interstellar objects transform from rare curiosities into, critical scientific targets that could reshape our understanding of galactic evolution and cosmic chemistry. Robert Jedica from the University of Hawaii estimates that technological advances, particularly the upcoming full operation of the Vera Rubin Observatory with its revolutionary LSST camera, promise to dramatically increase detection rates, potentially allowing astronomers to study dozens of interstellar visitors annually within the next decade. This technological revolution will create an unprecedented catalog of interstellar objects, providing statistical samples large enough to offer meaningful insights into galactic dynamics, planetary system formation processes, and the distribution of complex organic molecules across different stellar environments throughout our galaxy. Mark Norris from the University of Central Lancashire predicts that this growing database will reveal patterns in interstellar object populations that could answer fundamental questions about stellar evolution, planetary ejection mechanisms, and the chemical evolution of the Milky Way. As astronomers continue to unravel the mysteries of 3Y Atlas and prepare for an influx of future interstellar discoveries, humanity stands at the threshold of a new cosmic perspective, one that will fundamentally transform our understanding of our place in the universe and the evolutionary history of our galactic neighborhood, potentially revealing whether we truly are alone or part of a larger community of cosmic civilizations. As 3I Atlas continues its mysterious journey through our solar system, it carries with it questions that could fundamentally alter humanity's understanding of our cosmic neighborhood. Whether this ancient wanderer represents exotic natural phenomena or, something far more extraordinary, the implications are honestly staggering. The coming months will be crucial as this interstellar visitor approaches its closest encounter with our Sun, potentially revealing secrets that have traveled billions of years to reach us. Keep following InnoVision Tech for the latest updates on this developing cosmic mystery. Like, share, and subscribe.